Hello my dear students, I welcome you all to the first session of chapter on tangents and intersecting circles. Alright, so today we'll get introduced to the theorems that we are going to make use in the first exercise, that is exercise 18a, and with that we'll solve few sums as well. So the first theorem that we are going to use here is the tangent at any point of a circle and the radius through the point are perpendicular to each other. Now in order to understand this, let us take this diagram. For example, here there is a circle and there is a tangent AB. Okay, so we can say that P is the point of contact, right? So from your center, if you draw a radius towards the point of contact, that is OP, then this OP will be perpendicular to the tangent. Alright, so that's what is the meaning of this particular theorem. Now here it is said that OP will be perpendicular to AB. OP is perpendicular to AB. Okay, so the another theorem that we are going to use here is if two tangents are drawn from an external point to a circle, then the length of the tangents are equal. Alright, so there is a circle and from an external point, that means outside the circle you have to take a point and that point is P, and from this P you draw two tangents. So one is this tangent, that is PA, and another is PB. Alright, so according to the theorem, the length of both PA and PB will be same. That means if PA is 10 centimeter, then PB will also be 10 centimeter. Alright, so that's what is the meaning of this particular theorem. Alright, so you may pause the video to note down the theorems. Okay, so let us begin with the first problem. So question says the radius of a circle is 8 centimeter. Calculate the length of the tangent drawn to this circle from a point at a distance of 10 centimeter from its center. Now in order to understand this, let us draw the diagram. So there is a circle, okay, and you are drawing a tangent from a point P, which is lying at a distance of 10 centimeter from center O. Alright, so that means this OP is how much? It is 10 centimeter. Okay, and what is given? It is given that the radius of the circle is 8 centimeter. That means if you draw this tangent, let me take this point T to be the point of contact. That means this OT is what? OT is my radius. So that's why OT is 8 centimeter out here. Okay, now there was one theorem which said that this OT will be perpendicular to the tangent, that is the radius will be perpendicular to tangent. So that's why there is a sign of perpendicularity out here. Alright, so this is a sign of perpendicularity. Okay, so if it is the case of perpendicular, then this OTP, this is what kind of triangle? This is right angled triangle, because one of the angle is 90 degree here. Okay, so question says calculate the length of the tangent, that is we need to calculate what is PT. Okay, so since this is a right angled triangle, we make use of something called Pythagoras theorem. So all these things have already been mentioned here, so this is also given, right? So as OT is perpendicular to PT, so in right angle triangle OTP, then see here. So according to Pythagoras theorem, we have hypotenuse square is equals to perpendicular square plus base square. Now this is my 90 degree, right? So if this is my 90 degree, then the side opposite to this is called hypotenuse, that is OP is my hypotenuse. So that's why it is written OP square, that is hypotenuse square, is equals to OT square plus the remaining side, that is PT square. Okay, now let us put the values of the known quantities. Now we have OP is equals to 10 centimeter and OT equals to 8. So if I put the values, then I have 10 square equals to 80 square plus PT square, and we need to find what is PT, right? That is the length of tangent. So PT square will be from here. If you calculate, it turns out to be 36. That means if PT square is 36, then what is the value of PT? PT will be square root of 36, which is 6. That's why the length of the tangent is 6 centimeter. Since the units are given in centimeter, so that's why my tangent will also be in centimeter. Alright, so you may pause the video to note down. Okay, let's have a look at the next question, question number 2. So in the given figure, O is the center. So this is the given figure to us. So O is the center, AB is the tangent to the circle, to the B. Alright, so if AB is given to be, so the length of tangent is given to 15 centimeter, and AC, that means from here to here, so this is given to be 7.5 centimeter. So you need to calculate the radius of the circle. Okay, so again we know that this angle, that is OBA, so this has to be 90 degree because OB will be perpendicular to the tangent AB. Okay, so since this is my 90 degree, again we know that OBA, so this triangle is right angled triangle. Okay, so let me take the radius of the circle to be small r. Okay, so because we need to calculate radius which we don't know. Okay, so if this OB is my radius, then OC is also my radius. Okay, so we have AB and AC, which are 15 centimeter and 7.5 centimeter respectively. Okay, now in order to use Pythagoras theorem, I need OA, right? OA is my hypotenuse because this is opposite to 90 degree. Okay, so we don't know OA, but we know what is AC and what is OC, right? Because OC is my radius and I have taken radius to be small r, isn't it? So we have AO or OA, that is hypotenuse, will be equals to AC plus OC. Now what is AC? AC is 7.5, and what is OC? OC is R. OC is my radius. Okay, so I got my hypotenuse. Now we have this OB also, right? And we have AB also. So in right angled triangle AOB, we have this using Pythagoras theorem. Okay, so let us put the values. Now what is AO? AO is 7.5 plus R, right? AB is 15 and OB is again radius. So I put the values out here. Okay, now the next thing that you're going to do is you will apply A plus B whole square formula. Alright, so when you apply A plus B whole square formula, so you will have this in the left hand side. Please just don't copy, just evaluate this. Okay, so use A plus B whole square formula and make sure that you get this much. Okay, so we have 15 square is 225 plus R square. Now here R square, this R square and this R square can be removed. Okay, so from here if you calculate the value of R, then the value of R turns out to be 168.75 divided by 15, which is nothing but 11.25 centimeter. Alright, so you will verify these values by yourself. So you may pause the video to note down. Okay, let's have a look at the third question. So question says two circles touch each other externally at point P. Okay, so there are two circles which touch each other externally at point P. Okay, so P is the point of contact. Okay, now Q is the point on the common tangent through P. So through P you have to draw a tangent which is common to both the circles. That means this will be the tangent, right? So this line is a tangent which is common to both. So this is a tangent to this blue circle and both yellow circle as well at point P, right? So P is the point of contact for both the circles. Okay, and the name of this tangent is QP. Alright, okay, now you need to prove that QA, that is the tangents QA and QB, both are of same length. Alright, so that's what we need to show here. Okay, so that's what is written, whatever is mentioned out here. Alright, okay, so let me consider two circles with center O and O dash. Okay, now QA is a tangent to a circle with center O, and QB is a tangent to a circle with center O dash. Okay, now if you see only this, okay, so please discard this for now. So this Q is like my external point, right? So we know that if you draw any two tangents, if you draw any two tangents from an external point, that is QA and QP, to a circle, then both the tangents are of equal length. That is one of the theorem that we introduced in the beginning of the session, right? So we have QA and QP will be equal, right? So QA and QP are equal. Please remember, you have to forget about this circle for now. Okay, now in the next case, let me call this as equation A. In the next case, let me forget about this circle now. Okay, so let us forget about blue circle. Let us see that there's only yellow circle. Now if yellow circle is only present, then Q is external point, and from Q you are drawing two tangents to yellow circle. One is QP and another is QB, and we know that the length of QB and QP, again they will be equal using the very same theorem, right? So that's why similarly from point Q, QB and QP are two tangents to the circle with center O dash. So that's why I can say that QB and QP both are equal. Let me call this to be equation B. Now if you see here carefully, QA is also equals to QP and QB is also equals to QP, right? So that means from A and B, what we clearly say is QA must be equals to QP, right? Alright, so from A and B we have QA is equals to QB. So that's what we need to show here, right? That they are equal, right? So that's why the tangents QA and QB are equal here. Alright, so you may pause the video to note down. Okay, let us move on to the next question. So next question is also similar to the earlier question, but the only difference here is the circles touch each other not externally, but here it is the case of internally. Alright, so that's what is happening here. So there are two circles. This is a bigger circle, there's a small circle, and they touch each other internally. That is at point P. Okay, so again we need to show that the tangents drawn to the two circles from any point on the common tangent is equal in length. Alright, so there's a common tangent. So again, there's a small circle, there's a bigger circle, and the common tangent, that is the tangent which is common to both the circle, is QP out here. Alright, so from this point we have to draw two tangents, that is QA and QB, and we need to show that this QA and QB both are of same length, that is they are equal in length. So that's what is written out here. So let Q be a point on the common tangent from which two tangents are drawn. Okay, so there's a circle, smaller circle, and the center is O for smaller circle. And if you discard this bigger circle, again the case is same, discard this bigger circle and just think of smaller circle. Now for this smaller circle with center O, Q is lying in the external, right? So from Q you are drawing two tangents, that is QP and QA, and both of them will be again equal to each other, right? So that's why we have QA equals to QP. Let me call this to be equation 1. Now let us forget about this smaller circle. Now let us think that there is only one circle, that is bigger circle, whose center is O dash. Okay, now to this circle you are drawing two tangents. One is QP and another is QB. Again they will be equal to each other, right? So that's why it is written QB will be equals to QP. Again QA is equals to QP and QB is also equals to QP. Now if I combine 1 and 2, what is the meaning of this? This means that QA and QB both are equal. That means the tangents QA and QB are equal in this case as well. So you may pause the video to note down. Okay, let us have a look at the next question. So question number 5. Two circles of radii 5 centimeter and 3 centimeter are concentric. So there are two concentric circles. I hope you are aware with concentric circles. So concentric circles means circles with same center. Okay, so let me show you the figure out here. So this is the case of concentric circle. So if you see here, O is the center and there are two circles. This is inner circle and this is called outer circle. Okay, now you need to calculate the length of a chord of the outer circle which touches the inner circle. That means this outer circle is having a chord, so that chord is SP, right? And if you see here, this SP is the tangent for inner circle. That means this SP just touches the inner circle. So that's what you need to find here. So you need to find the length of SP. Okay, so there was one theorem which you have learned in class 9 circles chapter, that if you draw any line, from the center towards the chord, then that line will bisect the chord. That means here OT is the line, right, which is touching the line SP. So that's why here this SP gets bisected by the line OP. Okay, so not only bisected, but this will be perpendicular as well. Alright, that is OT will be perpendicular to SP as well. So this was the one which you learned in your class 9 circles. Okay, so we have been given that OS is the outer radius, right? OS is outer radius, and outer radius is given to be how much? 5 centimeter. Okay, and OT, that is inner circle. So OT means the radius of this inner circle. Okay, so OT is given to be how much? It is given to be 3 centimeter. Now as I said earlier, so this OT will bisect this SP, right? And again this OT will be perpendicular to SP as well. So can I say that this angle, that is STO, is 90 degree? Yes, so we have got this angle to be 90 degree. Now if this is my 90 degree, then this is what kind of triangle? This is again right angled triangle. Okay, so in right angle triangle OST, so OST is a right angle triangle, so I can say that this will happen. Now how? You have to mention by yourself. Obviously this is a right angle triangle, means you have to use Pythagoras theorem, and from Pythagoras theorem how do you get this? Now you might be wondering, there has to be plus or something. There won't be any plus. Please show how you get minus out here. Okay, now here as usual this OS is my hypotenuse, right? So here let us put the value of OS and whatever things we know here, right? So we know OS, so OS is 5 and OT is 3. So if I put the values, so 5 is square is 25 and 3 square is 9. So 25 minus 9 is 16. That is ST square is 16. That means ST will be square root of 16, that is 4 centimeter. Now as I said earlier, this OT will bisect SP, that is ST and TP both will be equal to each other. So can I say SP will be double of ST? Yes, we can say that. So that's why, as we know, OT is perpendicular to SP and OT bisects chord SP. So that's why I say SP, that is this length of the chord will be double of ST, right? So what is ST here? ST is 4. So that's why 2 into 4 turns out to be 8 centimeter. So my answer, that is the length of the chord, will be 8 centimeter. So you may pause the video to note down. Okay, let's have a look at the last question for the day. So question says 3 circles touch each other externally. That means we have got 3 circles which touches each other externally. Okay, so they are not getting intersected. If you see here carefully, a triangle is formed when the centers of these circles are joined. So let me call the center of this green circle to be A. Let me call the center of this blue circle to be B, and similarly C is the center of yellow circle. Okay, so if you join the centers, then you will get a triangle. So the question is talking about the very same triangle here. So find the radii of the circle. So you need to find the radius of each circle here. If the sides of the triangles formed are 6 centimeter, 8 centimeter and 9 centimeter. So the sides of the triangle being formed are given to be 6 centimeter, 8 centimeter and 9 centimeter. Now let me call the center of this green to be A, and let me call the radius of this green circle to be R1. Similarly, R2 is the radius of blue circle, and R3 is the center with R3 is the radius of yellow circle. Okay, now a triangle, let ABC be the triangle when 3 centers are joined. Now we have got the sides AB right? So AB can be written as R1 plus R2, right? Okay, so I don't know what are the 6 centimeter, 8 centimeter and 9 centimeter are referring to. We just know that they are the sides of the triangles. So let me call AB to be 6 centimeter, AC to be 8 centimeter and BC to be 9 centimeter. You can take anything. You can take AB to be 8 as well or 9 as well. But here I am taking in this order. Okay, so here AB means this line, and this line can be in fact written as R1 plus R2, right? Sum of the radius. Okay, and similarly we have AC to be R1 plus R3 and BC to be R2 plus R3. So we have R1 plus R3. So R1 plus R3 means AC, right? So AC is how much? 8. So that's why R1 plus R3 is 8. And we have R2 plus R3. So R2 plus R3 gives me BC. So BC is how much? 9. So that's why R3 plus R2 is 9. And the last one is R2 plus R1, that is AB. And what is AB? AB is 6 centimeter. Okay, so let me number it. So this is my 1, 2 and 3. Now if I add all of these equations, then we have in the left hand side R1 plus R3 plus R3 plus R2 plus R2 plus R1, right? And in the right hand side we have got 8 plus 9 plus 6. Now here you see that there are how many R1? There are 2 R1. Similarly you have got 2 R3 and 2 R2. So when you add all of this, 2 will be kept common and you will have this much. So you take this 2 to the denominator this side, so you'll get R1 plus R2 plus R3 will be 11.5. Okay, now let me call this to be equation 4. Okay, now let us use equation 1 and 4. So in equation 1 we have R1 plus R3. So instead of this R1 and R3, can I write 8? So if I write 8, then we have R2 plus 8. So we have R2 plus 8 will be 11.5. So from here you calculate R2 and this turns out to be how much? It turns out to be 3.5. Okay, so similarly we have using this 2 and 3 in the same way. Whatever I have done here you have to do in the same way. If you do that, then you will get R1 will be 2.5 and R3 will be 5.5. So that means we got R1, R2 and R3. That is the radii of each circle which the question is asking us to find. So that's why the radii of the circles are 2.5, 3.5 and 5.5. Alright, so you may pause the video to note down. Thank you very much.